All right, hello, my wonderful students. This is part 2 of Foldable number 2. Once again, we're going to be finding the perimeter and area, but this time we're going to be doing it of a pentagon shape. So we have our pentagon JKLMN. So we're going to go ahead and plot each of these first before we start our thing. So we have our -2, 5. This is our J. We have our 1, 1. Our K. Our L would be 1, -4. M is going to be -5, -4. So 1, 2, 3, 4, 5, -4. And, oh, sorry, I didn't label this one, M. And our N is going to be at -5, 1. We're going to go ahead and draw these out. We'll do it in green. That one. Last but not least. So for this one here, I know this is not a regular shape. It actually kind of looks like the home base. But we can see here that if we were to break this up here, we would actually have a rectangle and a triangle at the same time. So for this one, it's we don't really have a formula for the type of pentagon this is. But we do have a formula for a rectangle, and we do have the formula for the triangles. So that's what we're going to use. So to find the area, whenever we're doing these here, whenever you have a irregular shape like this, you basically find the area of each of the shapes by splitting it up, and then add them together. So we'll find the area of this one, write it inside, find the area of this one, write it inside, and then we'll add it together and find our true area. But in order to do that, first we have to find the length of all the sides. Luckily for us, all these are pretty even and they're all on the same kind of plane. So there's no, besides these ones here, which would probably be a little bit more difficult for we'd actually have to find each one to find the perimeter. But we're just going to focus mostly on the area for this one. So once again, we can count. If this was at, L was at -4, which is there. I know we kind of missed the mark a little bit, but it's supposed to be at -4. So we're going to count from -4 and go up to K. So we go 1, 2, 3, 4, 5. So we know the distance here is 5. And then from here we go 1, 2, 3, 4, 5, 6. So we know the distance here is 6. So the area is going to be our base times height. So the area here is going to be 6 times 5, which is equal to 30. And the area up here is going to be 1/2. And we have the base ready. Remember, the base is 6, but we got to find the height. So we got to find our imaginary height here. Remember, this has to be a right angle in order to do that. But I know this is actually easy because it's the level of K and N. And K and N's y coordinate is 1. So we just have to count from 1 to the y coordinate of J. So it'd be from here, it'd be starting at 1. So it'd be 1, 2, 3, 4. So we know our height is 4. That means we can write our area. Let's do it in green. Sorry, 1/2 base times height. I never finished my formula there. So the area is going to be 1/2. Which our base, which is 6, times our height, which is 4. And we can go ahead and apply the 1/2 to the 6. So we have 1/2 times 6 would give us a 3 times 4, which is equal to 12. So we know the area inside here is 12, and we know the area inside here is 30. So if we add our, the area of the total figure would be 12 plus 30, which is equal to 42. Now, to find the perimeter, I mean, we have our 5 here for this side, our 6 here. We know this side is also 5. This side is going to be the tricky one though. You know what? I'm just going to go ahead and say we don't have to worry about perimeter. Nah, you know what? It's not going to take too long. Once again, this is an isosceles triangle. I mean, I did it on purpose because it makes it easier. You only have to find the distance of one side, and it's the same as the other. So we're going to go ahead and find our triangle. So I know it kind of doesn't look quite like that, but this is supposed to be here at the same at this point. So it should be 3 and 3 here as well. So that means we have a 3, 4, 5 triangle. So this is going to be a distance of 5. Distance of 5. And I'll show you guys right now, because if we had our a squared, let's do it in red. A squared plus b squared equals c squared, we would see that our a plus b, so it would be our 3 squared plus 4 squared equals c squared. This would be 9 plus 16, which equals 25. So we already know that the square root of 25 is equal to 5. And it's also like a perfect triangle, 3, 4, 5 triangle. So it kind of worked out that way. So now we can go and find our perimeter. Go and do that in black here. So our perimeter is going to be equal to, we'll start on this side, go all the way around. Actually, we'll start at the 6. So we know once we get to the 6, we're done. So we have 6 plus 5, plus 5, plus 5, and plus 5, which got a little repetitive. And we know this is equal to 5 plus 5, 10, 15, 20, 26. So there we go. We have the area of both the shapes inside was 12 and 30, which add up to 42. So the area of the pentagon was 42, and the perimeter of the pentagon was 26. For this next one here, we had a crazy shape. It's the area, so I called it crazy shape because I actually didn't know what it was. But this one's mostly for fun. But I wanted you guys to do this one for practice. So you have A through I, so it's A, B, C, D, E, F, G, H, I. And I want you guys to graph it out and kind of do it for fun.